Okay, so fundamental desire of data mining is basically this diagram to take numerical data collected about some phenomenon and through some process of learning, right? This is a kind of conceptual idea of learning, derive some kind of knowledge. Okay, this is the basic diagram, but of course it's very problematic. We know a lot about this, right? But how do we understand learning as we relate to computer systems? And how do we frame this idea of knowledge? How do we know when knowledge has been attained? So we can look at learning, a typical definition of learning applied to humans, right? To human systems can be any one of these 5 things, okay? But if we look at these become a little bit problematic when we talk about machines and computers. So the first two, get knowledge about something by study. It's hard to apply this to a computer system. How do we know that it has knowledge? We can't talk to it. It doesn't have the same kind of brain that we do. To become aware, right? This is also a pursuit of artificial intelligence, but we're very far away from knowing if a machine can actually be aware of something. So those two are problematic. They're a bit specific about the human brain and how humans learn and become aware of things. The last 3 are a little bit actually too general. We of course understand what these things mean to a human learning system, right? But if we apply it to a computer, they're almost too generic or too easy, right? A computer is all about committing things to memory, so it can store things. But is storage mean knowledge, right? Not necessarily. To be informed, to receive instruction. These are all things that are very easy for computers, but don't necessarily translate to this idea of knowledge. So in our case, and this I'm taking from a book about machine learning, I didn't invent these things. This is like standard part of the profession. We reframe a bit our idea of learning and how we understand knowledge. And we say that things learn when they change their behavior in such a way that makes them perform better in the future. So you notice 2 key words here I bolded. Behavior, so we can analyze how something acts, right? And measure quantitatively if it acts in different ways in the future. We can apply this to computer systems and algorithms pretty easily. And here we say performance instead of knowledge. So we shift our understanding of how well this works from abstract ideas such as knowledge attainment, which we use in human systems, to performance. We can gauge performance again numerically. Okay, so this kind of definition is a lot better framework for computer learning. So machine learning takes the ability to make predictions as its main measure of performance. So again, the thing we're measuring is performance, and the primary way, it turns out, the easiest way to measure performance in a computer learning system is to measure how well that system can predict future scenarios. Okay, so you see this prediction a lot in machine learning, but as a matter of fact, prediction in itself, the ability to predict qualities of data that we don't know, is not an end to itself. Okay, in the kind of larger understanding machine learning, prediction is just a measure of understanding. Okay, so the better we can predict, the more we have hypothetically learned the system. Okay, in our case, that distinction is very important because prediction a lot of times is the main kind of application of machine learning. So you see Netflix trying to predict the movie we want to watch, Amazon trying to predict what books we want to read, Google trying to predict what we're going to search for. Okay, so in practice, prediction in and of itself becomes a goal of machine learning. But in the theory of it, and when we think about applications, our applications for machine learning, prediction is just a measure. Okay, and there are plenty of other applications we can think of in terms of a computer learning complex system beyond just predicting the next iteration, right? Somehow, if we predict well, there's some understanding in the computer, and we can derive that understanding from it, some kind of structure or knowledge that we can transfer to our own knowledge. For instance, machine learning, a data set about the city can actually help us learn something about that city, not just predict what's going to happen next. Okay, it's very important. Here, a quote that we'll get to in 2 weeks. This is one of our readings, the last reading session. It's an amazing, super fun reading. Kevin Kelly in the 90s wrote this book called Out of Control. And he basically makes the argument that telling the future or making predictions is not just a human pursuit. It's a pursuit of any system, because that's usually the only way that we measure the way we learn. You can think about kids learning the same way, right? You touch a stove and you get burned, and then you create knowledge, right? You know not to touch the stove, but that's because you're predicting that the next time you touch it, it will hurt the same way again. Okay, so prediction as a measure of learning is really important.